The trapezoid ABCD is isosceles, and the length of each leg is 15. The length of AD is 30, and the length of BC is 8. From vertex A, we draw two line segments that intersect sides BC and CD, and the distances from the points of intersection to vertex C are X and Y. These two line segments divide the trapezoid into three regions of equal area. What is the value of X plus Y? First, we need to find the area of the trapezoid. We begin by drawing the altitudes of the trapezoid. Take a look at these two triangles. Both of them are right triangles. Therefore, we can use the Pythagorean theorem to find the height of the trapezoid. 6 squared plus h squared equals 15 squared. 6 squared equals 36, and 15 squared equals 125. Subtract 36 from both sides. H squared equals 189. Now, simply take the square root of both sides. H equals the square root of 189. Before we find the area of the trapezoid, we need to determine one more thing. Since this is an isosceles trapezoid, angles A and D are equal, and angles B and C are equal. Also, angles A and D are supplementary to angles B and C. Therefore, the sines of all four angles are equal. All we need to do is calculate the sine of angle D. Using this right triangle and the fact that the sine of angle D is the ratio of the opposite side to the hypotenuse, we can find the sine of angle D. The sine of angle D is equal to the square root of 189 over 15. Now, let's find the area of the trapezoid. The area of a trapezoid is equal to its height multiplied by the average of its two bases. Therefore, the area of the trapezoid is equal to the quantity 30 plus 18 divided by 2, multiplied by the square root of 189. Its value is 24 times the square root of 189. Now, let's add those two line segments back to the figure. Since the figure is divided into three equal regions, 24 times the square root of 189 is equal to 3 times the area of each region. Finally, the area of each of the three regions is 8 times the square root of 189. Now, let's express the distances from the intersection points of these two line segments to vertices B and D in terms of X and Y. Take a look at the two triangles formed on the sides of the figure. Using the area we found and the sine of the trapezoid's angles, we can determine the values of X and Y. Let's start with this triangle. 8 times the square root of 189 equals 1/2 times the quantity 15 minus y times 30 times the sine of angle D. Substituting the value of the sine of angle D, which is the square root of 189 over 15, the only thing left to do is simplify the equation. 8 equals 15 minus y. So y equals 7. Now, let's do the same for this triangle. 8 times the square root of 189 equals 1/2 times the quantity 18 minus x times 15 times the sine of angle B, which is also equal to the square root of 189 over 15. All we need to do is simplify it. 2 times 8 equals 18 minus x. So, x equals 2. Finally, x plus y equals 9. Thanks for watching this video. If you enjoyed this problem, don't forget to like and subscribe. Goodbye.